Okay, thank you. Over the last 70 years, there have been many physicists that have been involved in the nuclear weapons issues, technically, policy-wise, and politically. Many of these were remarkable physicists who made enduring contributions. We just heard about one, we just heard from one, and there are others in the front row here. But what I'd like to talk about is engaging the physics community at large, the community of non-experts. The thesis is that this is a serious enough threat to us all, that physicists who are informed about the problem but not necessarily experts can play a role in mitigating the threat. This talk is a little different than the prior three in the sense that I'm not an expert in this area. My research area is plasma physics, and I've just recently become engaged in this topic. So with that confession, let me begin. The motivation, the motivation is that the nuclear threat remains severe and is arguably getting worse. However, the threat can be reduced. There are feasible steps that can be enacted to reduce the threat. And the physics community, as I said, if organized, if informed, and if the awareness is raised, can play a role in advancing this cause. The physics community has a special relationship to nuclear weapons, obviously. We invented them, we maintain them, we evolve them, will be needed to verify that they're dismantling. But presently, this issue is, I believe, almost completely off the radar of the physics community collectively, as it is for the general public. So the thesis is if the physicists were to get involved, this community can be an influential voice in this discussion. So what I'd like to do in my talk is first remind you about the threat. And this reminder is not for the experts in the audience. They will find it pedestrian. It's for the non-experts. So I'd like to describe how it is that the threat is increasing, and this involves some policies that are unfavorable. So this is why there's a need to do something. And things can be done, so I'd like to review some of the favorable policies that have been enacted and steps that can be taken to reduce the threat. So it is a problem that progress can be made. And this is this reminder of the threat and that it's not hopeless is meant to motivate the interest of the non-expert physics community in this problem. And then I'll describe what the physics community can do, some past efforts by the public, and after all, we're part of the public, and by the physics community, and then I'll describe very briefly a formative initiative that Frank referred to that's under discussion. The nuclear threat is severe and getting worse, arguably. There's been a gradual proliferation, so the landscape is getting multipolar and complex. There are nine weapon states, the original 5 that were enshrined in the Nuclear Non-Proliferation Treaty, plus 4 more. They're listed there. These states are very diverse in their size of their arsenals, in their forms of government, in their perspectives on the world. So this makes it a very complex environment. Collectively, there are reportedly over 9,000 weapons in the military stockpile. This has a yield somewhere in the range of several 100,000 Hiroshima bomb equivalents, so it's still a very fearsome and frightening level of destructive power. In addition, there are about 1,900 weapons that are warheads that are on alert status and can be launched within minutes. So this is a scary prospect. And what are the implications? Well, with the gradually increasing number of nuclear weapon states, there's an increasing number of scenarios for nuclear war. It's not just potential nuclear war between Russia and the US. I don't think the number of scenarios goes like n squared, but it does increase with the number of weapon states. There's a greater risk of an accidental detonation. There's a historical catalog of many close calls or near misses, whereas George Carlin calls it near hits. Near misses is really a euphemism. There have been many false alarms where the US or Soviet Union received a false signal of an incoming attack, alerting forces with disaster narrowly averted, and various mishaps with missiles. And one could really have a fear that at some point, N gets big enough and the landscape gets multipolar and complex enough that you can imagine maybe a tipping point where it gets ever more difficult to unravel. There's also with more players, a greater likelihood of a regional war, which would have an effect on the global climate. And so, for example, climate scientists have considered a war, hypothetically, between India and Pakistan, a significant war in which each launches 50 Hiroshima-sized 15-kiloton nuclear weapons, which is just 0.1% of the world arsenal. And what this would do, it would ensue fires that could loft, according to the climate scientists, about 6 million tons of carbon soot into the stratosphere. This would reduce the global temperature by about 1.25 degrees Celsius, more over specific land areas, for about 10 years. And you can see that in the plot there. The temperature over China versus the baseline is reduced 1 to 2 degrees over about 10 years. Climate scientists predict that crop production would be reduced by 10 to 20% in various crops around the globe. And health scientists infer that such a reduction in crop production could put upwards of 2 billion people in the peril of famine. Now, being only a physicist, I have no idea if this 2 billion number is anywhere near accurate. I have no idea. But even if it's an overestimate by a factor of 10, that would be 200 million people outside of India and Pakistan, which would be 10 times greater than the direct fatalities from the war itself within India and Pakistan, which would be 20 million people. So a regional war has a global impact, and no such thing as a contained nuclear war. There's also the increasing threat, this has been well publicized, of non-state actors, terrorists. There are presently about 1,800 tons of fissile fuel around the world in form of uranium and plutonium, which is enough for about 200,000 weapons. And here you can see a plot of the weapons equivalents of uranium and plutonium stockpiles in different sectors, the military, the naval, civilian, and so on. And you can see, for example, just in the civilian sector alone, I guess this pointer doesn't work. Well, there you go. The civilian sector alone, with plutonium, there's the equivalent of about 60,000 nuclear warheads. In addition, about 20 nations have sufficient fissile material for nuclear weapons. Yeah, that's good enough. Thanks, Joel. There's also an increasing threat of cyber attack, which can undermine the integrity of the nuclear weapons complex. You can imagine what cyber attacks can do. They can attack an early warning radar so that a nation could be blind to incoming missiles initially. They can attack the communication systems. If they disable the communication between the nation's leader and the military, what happens in the case of an attack? Or they disable the communication between nations, how do you negotiate your way out of a nuclear conflict? It can provide a false warning of an attack, or it can hide an attack. It can enable the unauthorized use of warheads. These are all threats by the increasing power of cybersecurity, which can thereby cause a catastrophe if it were to occur, and generally just undermine the confidence in the integrity and reliability of nuclear weapons systems. This worsening has been happening for quite a while, but at this present moment, I think there's an acceleration in the rate of worsening, if you like. There's been a spate of withdrawals from treaties, withdrawals from the Iran nuclear deal, from the Intermediate Nuclear Forces Treaty. This follows a withdrawal from the ABM Treaty in 2002, and the New START Treaty is up for renewal in 2021, and that's possibly in question. There's a potential development of new low-yield weapons in the US and in Russia, and you can argue that those are destabilizing and not needed. There's, as was described in previous talks, a massive modernization of the weapon systems, which will commit the US and Russia, perhaps China, to nuclear weapons to the end of the century. There's a potentially decreasing threshold for nuclear warfighting. Both the US and Russia, in their stated policies, talk about a nuclear response to a non-nuclear attack. And there's been an increase in saber rattling. And a lot of this was led, actually, just 2 years ago, William Perry, to say that we stand today, and this is in 2017, in greater danger of a nuclear catastrophe than we faced during the Cold War. Most people are blissfully unaware. So this is depressing. However, the problem is controllable. And there's been enormous progress throughout the decades through various agreements and voluntary actions. It could have been even worse. And I want to describe some of those to indicate the positive side that things can be done. Well, the cornerstone of the present regime is the Nuclear Non-Proliferation Treaty, signed by everybody except 3 nations, and North Korea has since withdrew. In this, the non-nuclear weapon states commit not to develop weapons, and the nuclear weapon states, the 5 that were weapon states at the time, committed to the cessation of nuclear arms race at an early date and to nuclear disarmament. The effect of this has been significant. Over the last 50 years, there's been an expansion only from 5 to 9 nuclear weapon states. And you can see here, there's been a gradual proliferation. But this is much less than was predicted by many decades ago. Many said that we would have dozens of nuclear weapon states now. So this has been very effective, although not completely. It set a legal requirement on the nuclear weapon states to disarm, and that has not yet been fulfilled. There's been a drastic reduction in nuclear weapons since the 1980s, and here you can see the US and the Russian stockpile of warheads, and you can see there's been a mammoth reduction. This is still a catastrophic number, but it's much less than it had been. This was facilitated by a series of treaties. There's been an elimination of the ground-based US and Russian land-based missiles of intermediate range. This is through the INF Treaty. Through the INF Treaty, about 6,000 warheads on 2,700 missiles were eliminated, mostly on the behalf of the Soviet Union, and only 1/3 on the behalf of the US. This was part of a very dramatic reduction of US warheads in Europe, which was brought on due to public pressure and the collapse of the Soviet Union. So here's a plot of the US warheads in Europe. And around the 80s, there was public pressure and then the collapse of the Soviet Union. So there's a massive reduction of US warheads in Europe, which eliminated the very destabilizing ability to launch a missile between Europe and Moscow with only a 10-minute warning. There's been no nuclear weapon testing almost since 1996. Before 1996, there were about 2,000 tests underground, in the atmosphere, and underwater, with a collective yield of about 500 million tons. In 1996, the Test Ban Treaty was signed, ratified by 167 nations, although not the US. And since 1998, the only nuclear tests have been in North Korea. And the absence of testing has been a substantial barrier to nuclear weapons development. This is, I think, an encouraging plot. About 20 nations have voluntarily started and then stopped their nuclear weapons programs. And this is a plot of the number of states that have started and stopped their nuclear weapons program. So it doesn't include the 9 nuclear weapon states. So for example, in 45, Switzerland started a program, and then Brazil, and then Sweden and Yugoslavia, and so on. But you can see that in this year, Australia stopped their nuclear program, so you got a drop in the number of weapon states. So it's gone up and down, but 20 have voluntarily given up their programs, and South Africa voluntarily dismantled 6 existing nuclear weapons. A good part of the world lives under nuclear weapon-free zones. There are 6 treaties that establish 6 regions of the world as zones within which nuclear weapons are not allowed in any way, in any fashion, from manufacture to possession. These treaties cover Latin America, the South Pacific, Southeast Asia, Central Asia, Africa, and Antarctica. Most of these treaties, in turn, get an assurance from nuclear weapon states that they will not be attacked by nuclear weapons. So if you look at a map, all these red states are the 9 nuclear weapon states, and all these blue countries are part of the nuclear weapon-free zone. So the entire southern hemisphere is committed by treaty to being free of nuclear weapons. You might ask, well, why not just extend that to the northern hemisphere and the problem would be solved? And most recently, and this was mentioned previously in a talk, There's been a treaty developed under UN auspices to completely prohibit and make illegal everything related to nuclear weapons, from development to the threatened use. In 2017, adopted by a vote of 122-1, this treaty was adopted. 69 states did vote, all the nuclear weapon states and all states under their umbrella and all of NATO. To enter into force, it requires ratification by 50 nations, and to date, although 70 have signed, only 21 have ratified. But this kind of sets a guideline for the world, a moral guideline. So what are some feasible actions that can be taken to reduce the threat? And a lot of this was covered in previous talks. Anything that increases the time to launch is tremendously stabilizing. So de-alerting, taking those 1,900 warheads off of hair trigger alert would be tremendously beneficial. Demating, separating warheads from missiles, further extends the time from a command to launch to perhaps hours or days. That gives times for things to calm down. And actually, a complete and utter disarmament of the world only extends the launch time, because any country can redevelop weapons over some period, whatever it is, maybe months. But that is tremendously stabilizing. We feel much, much more comfortable that most of the nations of the world, even though they could, don't have nuclear weapons presently. One can abandon the launch under warning policy that was much, or option that was much discussed. Adopt a no first use policy. It's hard to imagine a situation where you would need to use a nuclear weapon first. I think Steve spoke a lot about the idea of eliminating ICBMs as being a unnecessary and destabilizing component of the triad. One can reduce the huge stockpile of weapons usable fuel, and finally extend the New START beyond 2021, which will maintain the cap on the number of warheads, and then one can continue negotiations for bilateral reductions. It's often said that nuclear weapons cannot be uninvented. A lot of physicists tell me this, and of course that's true. And then it's also said that the genie cannot be put back in the bottle, and that's not true. The genie can be substantially, not completely, but substantially put back in the bottle. So government leaders are not, at this moment, very much reducing the threat. The threat requires pressure from the public. The physics community is part of the public and can play a role. So let me just look backwards a little bit, some examples of past public pressure, and then I'll get to the physics community. There have been some nice examples. There was a very strong public resistance to the siting of defensive missiles in the vicinity of urban areas in the 70s. The government wanted to put defensive missiles that were tipped with nuclear warheads to shoot down incoming warheads with nuclear explosions. Physicists and activists merged to oppose this. There were not in my backyard movements in Chicago and Boston and in Seattle. You can see here's a cartoon from the New York Times. It says, you can't see it, there goes the neighborhood, and there's an ABM being moved into the neighborhood. Physicists played a significant role in alerting the public to it and providing information, and this opposition was successful. It contributed to the 1972 Anti-Ballistic Missile Treaty. There was a massive resistance to siting US missiles in Europe in the 1980s. A NATO plan to deploy over 500 intermediate range US missiles in Europe. 3 million people protested across Europe, and this was successful. It contributed to the signing of the Intermediate Nuclear Force Treaty. There was a nuclear freeze movement in the United States in the 80s to halt the nuclear arms race. This was a massive, I mean, it's hard to imagine this happening today. There was a 2 million person petition to the US and the UN. There was a 1 million person demonstration in New York Central Park. 9 states voted for a freeze. 72% of the population supported it. It was part of the Democratic Party presidential platform in 1984. And reportedly, it influenced the thinking of Reagan, which led to the massive arms reductions that followed, exceeding actually the ambitions of a simple freeze. So what is the view of the public presently? And that's hard to capture, and I'll just cite a few recent surveys. A recent survey showed that the public is perfectly willing to use nuclear weapons in some situations. This is a little bit shocking. It's reported that 56% of the public would support a nuclear attack on Iran that led to 2 million fatalities rather than a US invasion that led to 20,000 US fatalities. A very recent study. That's kind of shocking. It's clear that this issue is off the radar of the public. It's not in the top 10 issues of concerns by any surveys, except for issues of the day like terrorism in North Korea. But this is encouraging. The public is predisposed toward arms control. 49% favored staying in the INF Treaty, 20% didn't know. And in a 2008 poll, 77% of the US favors an international agreement to abolish nuclear weapons, and that's true worldwide also. So what I conclude from this is the threat of nuclear catastrophe is off the radar of the public, but there's a latent concern that can be sparked and used effectively. So let's go to physics community. In the early days, there were early statements by very elite and expert scientists of the day. In 1945, there was a Frank report demonstrating the bomb and not using it. It had 7 signatories. In the same year, there was a Szilard petition that argued against the use and very wisely warned of an arms race. It had 70 signers from the Manhattan Project. In Germany, in 1957, there was a manifesto of 18 nuclear scientists, including, for example, Heisenberg, that recommended to desist from nuclear weapons development and said they would not participate in nuclear weapons development. And this played a tangible role in Germany giving up its nuclear weapons program. There was a 1958 petition to end nuclear testing with 9,000 scientists from 43 nations. This was not just physicists, led by Linus Pauling. And in 1995, somewhat recently, but Hans Bethe issued a call on all scientists in all countries to cease and desist from work creating, developing, improving, and manufacturing further nuclear weapons. There were more recent statements and petitions. In 1986, there were 6,000 faculty and graduate students pledged not to engage in SDI research. This was actually co-instigated by Elizabeth Groland at the time. In 2017, there were over 3,000 scientists, not just physicists, signed a statement in support of a nuclear weapons ban. As I mentioned already, physicists played a role in opposing ballistic missile sighting. And of course, there are currently ongoing many NGOs that have heavy physicist involvement and they have made exceedingly effective and high quality contributions academically and politically. So what I would conclude about the physics community is, well, first I'll say, despite all these above impressive accomplishments, the problem persists and is getting worse. What I would conclude about the physics community is exactly the same as I would conclude about the public at large. The threat of nuclear catastrophe is off the radar of our community, but there is a latent concern that can be sparked and used effectively. So that brings me to an initiative that we've been discussing to try to help get the physics community involved in this issue. And this has been discussed at Princeton with Frank and with Zia Mian, and Steve Fetter kindly agreed to be part of it, and others. So it's an initiative to engage and activate the US physics community in nuclear threat reduction. It's currently being developed, and we hope to be able to start this initiative in the fall. The goals are to inform and activate the physics community in this issue. And there would be 3 phases to this project. The first would be to educate. That would be informing them and engaging. The second would be organizing the community in some sense so they can be employed to argue for threat reduction. And the third phase would be using it for advocacy. The first 2 steps would be accomplished simultaneously. So the approach would be we would employ a team of experts who would visit physics institutions around the country, universities, labs, and industry, and have maybe 1 or 2 experts visit each physics institution. We're thinking a senior expert and an early career scientist to facilitate outreach to junior physicists. At each institution, a colloquium would be delivered that would give a comprehensive picture of the problem to try to raise the educational level of the community and engage them. We would also lead a discussion at each institution on this issue and how one can mitigate the threat, and identify key individuals at each site who would spearhead advocacy, sort of establish advocacy modes. And then we would integrate all these visits to establish a national network or a roster of physicists who would be willing to devote some time to argue to mitigate this threat, people that are well informed but not necessarily experts. And this would be facilitated centrally. We would aim to visit about 100 institutions distributed nationally, maybe beginning with strategically key states and then branching out nationally. We visit the country. What's plotted here is not where we necessarily visit. These are, by a study by the NRDC, these are nuclear attack sites in the country that would enable elimination of 1/4 of the population of the United States, with somewhere over 100 warheads. So we might try to visit these cities. And this plot is a plot of the relative concentration of physicists in the United States. And I remind you that for scale, there are about 55,000 APS members. So in this bottom one, the dark red have the highest concentration of physicists, and then as you get lighter, you get less and less physicists. And actually, the concentration of physicists resembles somewhat the target sites for nuclear weapons, so maybe that will motivate them. The mention will employ a team of about 10 experts. We will also include outreach to physicists that are presently underrepresented in the nuclear arms issue, specifically women and minorities, and visit institutions and conferences that give us access to that demographic. This effort would be entirely nonpartisan with a strong educational component, and we're hoping to get the institutional support of the APS, which would facilitate this. And we imagine that this first education and organization phase will require 2 years of effort. Once this has happened, imagine 2 years from now, we've elevated the interest in the community, and we maybe have a roster of individuals willing to work on this distributed nationally. What would we do with it? Well, we would use a network to foster and advocate for nuclear threat reduction. We would hope to be able to partner with existing NGOs that already are active and have expertise in this area. And there are various ways you can advocate to be determined. The most straightforward is to argue for specific focused steps to reduce the effort, as have been discussed. A no first use policy, no launch and warning option, and so on. Perhaps there would be a community consensus that would emerge. I have no idea if one existed. One can use such a consensus. And then this would be very challenging, but one can imagine if this was successful to try to partner internationally to explore whether such an initiative can be formed in other nations or whether there could be a partnering on specific issues. Look back in history, a lot of progress has been made when there's been crosstalk between the US and the Soviet Union and other nations. I might say if you're interested in engaging in this initiative in any way, you can please contact me. And to conclude, last April there was a Physics Today article by actually Steve Feder, Richard Garwin, and Frank von Hippel, all who are in the first row. And they had a very nice article I recommend it to you on nuclear weapons. And the tagline below the title from these three said, "With the end of the Cold War, most physicists turn their attention away from the nuclear threat. It is now time for us to re-engage in the debate over how to reduce the danger of nuclear weapons." With that, I'll say thank you.
Reactions to some thoughts? Any thoughts?
Yeah.
You mentioned right at the end an area of advocacy extremely important in the past.
Which scenario?
Did you mention in the end the issue of having conversations with scientists in Russia,
Yeah.
China, elsewhere? Actually, United Nations Security Arms Control International Academy of Sciences, Upwash, all Dodi, that had tremendous influence back 20, 30 years ago. I'd be interested to know what are efforts going on right now. Dick might know with CSAC related to discussions with the Russians, with Chinese, and with
Yeah, I mentioned the Dodi Group, the first Dodi Group that met with the Russians beginning in the 1960s. And although I was not at Harvard, I was a member of that. And it was really very important, continued and was more formalized so that it was under the American Academy of Arts and Sciences. And I remember it had a new life in 1980, 1981 or so. And we had discussions of forbidden radars under the 1972 ABM treaty, and brought new people on the Soviet side into the discussions. And then it was taken over by the National Academy of Sciences, the Committee on International Security and Arms Control, and expanded in 1988 to meet once or twice a year with a group of Chinese scientists. Our counterparts in China were and are the IAPCM, the Institute for Applied Physics and Computational Mathematics, which is really the theoretical nuclear weapon design group that built the original fission weapon, Chinese fission weapon, and then the thermonuclear weapons. And we've had a good interaction with them, and in fact, discussed with them thoroughly the Comprehensive Test Ban Treaty and the role of peaceful nuclear explosions in leading up to their signing and our signing of the CTBT. So I think it's had a good effect. It's broadened into other areas because they developed a program in arms control in the IAPCM and then a division in arms control and have branched out. And they realized the necessity of doing something about cyber weapons by inadvertence or maybe even biological weapons. So it's been pretty good, but it's a track 2 operation and reports to the governments on both sides, but doesn't have any government participation, even though, of course, all the Chinese are employees of the Chinese government. But they're real technical contributors for the most part. Thank you.
So I hope this isn't too far off topic, but when I think about all the funding that goes into either national labs or private industries that's related to maintaining and I don't know, probably not developing, but there's a lot of funding associated with nuclear weapons and that sort of field. How do you think that's going to influence the future of denuclearization?
Well, I think there's one obvious. There's a lot of funding that goes into the national laboratories and development of nuclear weapons. Things that how do I think that's going to influence policy in nuclear weapons? Is that correct? Right. Yeah. Well, the obvious answer is that it's a huge driver for the development of new weapon systems, maintenance of the weapon systems. So it sets up a huge complex of vested interests. That's the obvious answer, and I think that's you can expect that to continue.
Okay. Thank you.
I remember on the fall of the Soviet Union, there was concern about the amount of highly enriched uranium plutonium around, I think you said 200,000 warheads. And an attempt to turn that into fuel for energy. Is that an issue that can be used to reduce threat? Does that have any legs at all?
Yeah, so standing here is Frank von Hippel, who's an expert, so I'm going to let Frank answer.
Well, there was a proposal by Tom Neff, who associated with MIT, who was the father of this so-called HEU deal, where the Soviet Union, while it was, and then the Russia, while it was economically in dire straits, actually sold to the United States 500 tons of excess weapons uranium over a period of 20 years, which provided half the fuel for U.S. nuclear power plants for that period of 20 years. There's more where that came from, but that's not the most important reason to take the warheads apart.
I guess my question is sort of about the general situation. It seems like the assumption here is that the unawareness of public and maybe the governments can be changed by such a program. But how do we know that the governments are unaware and that they are actually going to be listening?
Boy, I don't think the government's unaware. There was, and will they be listening? So, all I can give is general answers. Governments do listen to pressure. The physics community is a small community, but I think our voice can be influential on this issue. The government is informed. Yesterday there was a hearing on nuclear weapons, two-hour hearing, and it was extremely educational to hear this. The government, as represented by the congresspersons on that hearing, have very strong fixed opinions on nuclear weapons and the need for nuclear weapons. And those fixed opinions in Congress, I think, are quite different than, I would say, the experts in this first row. They're informed, they're intelligent, and I think they can be influenced.
One thing you didn't recommend is for a sort of study such as the APS has done or other groups of physicists have done over the years, kind of commenting on various political proposals for nuclear weapons or missile defense. I'm curious if you think that's not a strategy likely to be effective now, or why you didn't include that.
I think that would be very effective. I didn't include it only because it wasn't my topic. My topic was engaging the community at large. But I think I think you make a very good point with the modernization that was discussed, with the some addition of new weapons, the push for low yield weapons. I think there's many topics that would benefit from APS studies that you refer to.